Alright, y'all, how y'all doing? I probably should have given y'all a hint to this. Apologize for that. I just didn't. Anyway, assuming, right? Sorry. So, what's going on here is this kid who's precocious and likes to be annoying decided he's going to take his slice of pizza like this. Now, if you remember, anytime the hypotenuse or the side of a triangle inscribed has the diameter, and this is a right triangle. Now that's not going to be really helpful, but that is true. The reason why that's not helpful is because then we would have to find the area of that right triangle, which we probably could do, but how are we going to find the area of this segment? Okay, well let's just not do that. We can find the area of this segment. But this would be a lot easier if we found the area of this upper triangle and we found the area of that sector. Now, we know two things. We know that the diameter is 12, which means the radius is 6. So that's why you see the 6's here and here. We also know that there was a straw that was 5 inches perpendicular to the diameter, which would enable the side on the left of the triangle to extend to the point end of the straw at A, which means we have a right triangle, since tangent to C is always a right angle with the diameter or hypotenuse. Again, anytime you have a circle, whatever the radius is, a tangent to the radius is always a right angle. And so that's what's happening right here. Alright, so we know the straw is 5, we know the diameter is 12, so we can find that's 13. So this is 13. But it also includes this side, which means we don't really know the chord BD. We know the chord BD is part of the 13, but it ends somewhere around here. So here's the circle. Oh, darn it. Here's the circle. Okay, and this right here would be point D. Okay. The basis of this problem is in relationship to the angles. And you might remember me showing you this when we were looking in chapter 7 at the half angle formula for the tangent. There was an alternative way of doing it, and I should use this to show that to you. Alright, so we've got two isosceles triangles here. We know that both of these angles are congruent. And so that means if we call that x, this is also x, which means that angle right there is 180 minus 2x. Well, I called that angle M. Okay? And then the reason n is 2x is because then this angle right here is 180 minus that. Okay, well you subtract the 180, you get 0. So this equals 2x. Okay, so that's the basis of this problem, establishing the angles. So if we don't establish the angles relationships, and this is going to be hard. So this is x, angle n is 2x, and angle m is 180 minus n, or 2x. So that's why I put m here and n there. Alright, now how do we get the angle? Well, again, this is angle x. This is a right triangle. The opposite over the adjacent is the tangent. So we can use 5 over 12 equals to the tangent of x. Find x by using the inverse tangent. And that would be, where did I put that? 22.619. So this is 22.619. Okay, so that's x. 2 times that is angle n. Subtract from 180, you get angle m. And that's these two angles, which would be these two angles. Okay, now this is the angle of area of a triangle. So notice the angle in between the two sides. So 1/2 6 times 6, the sine of the angle m. And this is the area of a sector, and since we have degrees, this is a portion of a circle area based on the ratio of degrees to 360. So whatever this is out of 360 is the percentage of the area, which would be pi r squared. Okay? Now y'all take it easy out there. I gave y'all a little area problem based on a quilt, which doesn't involve trigonometry at all. So you're getting a little break. I'm getting some information from the district probably later on today. And when I find that information about what we're going to do, I'll let you know. All right, y'all take care.